So in this video we're going to be graphing a couple of sinusoidal curves using transformations that will involve phase shifts. So first example we have here is y equals 3 times the sine of pi x minus pi. So first thing I'd like to take a look at will be the amplitude as well as the amplitude modulation. Amplitude modulation is determined by the coefficient that we see in front. That'll be multiply the y values by 3. As such, the amplitude is going to wind up being the absolute value of 3, which in this case would simply be 3. Now for our horizontal transformations, that'll be for both the phase shift as well as the frequency modulation. We're going to take a look at what happens over the course of one period. One period should go from 0 to 2 pi, with the angle being on the inside. Angle in this case is referring to pi x minus pi. So we're going to keep track of the algebraic steps that we take in order to solve this. First thing we'll do is add pi to all three parts. So for the operation over here, we'll point out we're going to add pi to the x values. So we get that pi x is now between pi and 3 pi. To finish solving for x, we're going to finish by dividing through by pi. So all three parts get divided by pi. We get that one full period wavelength cycle is going to go from x equals 1 to x equals 3. Now that tells us two things. The phase shift, in this case, is going to be equal to whatever the starting point for the period is. And the length of one period, there are two different ways to do it. We can either do 2 pi divided by omega, which is pi, or we can simply take the ending point minus the initial point, and we will get the length of one period. That'll be 2. Additionally, I should probably point out what our bad mother function is, and that is going to be y is equal to the sine of x. So what I'm going to do is come down here, and we're going to start with y equals the sine of x. The corresponding values that we'll be using. We'll start with 0, pi over 2, pi, 3 pi over 2, and 2 pi. Corresponding values for the sine function will be 0, 1, 0, negative 1, and 0. There are a total of 2 horizontal transformations to do. First one is to add pi. Adding pi to each of these values with a common denominator would be adding 2 pi over 2, so we'll call that pi, 3 pi over 2, 2 pi, 5 pi over 2, and 3 pi. Please note that the pi and the 3 pi that we get here are the same as the pi and the 3 pi that we got as part of the process back here. Then we'll apply our frequency modulation and divide by pi. All that that's going to do is simply cancel out all of the factors of pi, and we'll get 1, 3 halves, 2, 5 halves, and 3. Now, the difference between consecutive x values is 1/2, so I'm going to use an x scale of 1/2 when I graph this. We also need to apply our amplitude modulation, and the amplitude modulation was to multiply the y values by 3. So the zeros will remain the same. The 1 will get tripled, and the negative 1 will get tripled as well. So I've already mentioned I want my x scale to be 1/2. So it'll be 1/2, 2 halves, 3 halves, 4 halves, 5 halves, 6 halves. That'll get us our first cycle. For a second cycle, we'll need 4 more points beyond that. So 7 halves, 8 halves, 9 halves, and 10 halves. Maximum values will be at positive 3, minimum values will be at negative 3. So we'll start by plotting the ordered pair 1, 0, then 3 halves 3 up to a maximum, back to the midline, down to a minimum, and back up to the midline, as is typical for a sine function. Now if we're interested in drawing a second cycle, you can extend either to the left or to the right, as long as we get at least 4 more points. If we were to go to the left, then we connect the midline up to a maximum, back to the midline, down to a minimum, and then back to the midline. And once again, we'll try to connect that smoothly and continuously, just like so. A couple arrows at the end so that we know that this pattern repeats itself. The domain for this function will be all real numbers, and the range, as demonstrated by the amplitude, will take us from negative 3 to positive 3. That'll be 2 full cycles of our sinusoidal curve. Let's try one more while we're all together. Let's try this one out. Graph using transformations, we have y equals negative 4 times the cosine of 2x plus pi over 3. So let's actually note the mother function first this time. It is y equals the cosine of x. After that, for our amplitude modulation, we are going to multiply the y values by negative 4. This also lets us know that our amplitude is going to be equal to the absolute value of negative 4, which is positive 4. For the phase shift and frequency modulation, we'll take what's inside the parentheses, that is our angle, and we're going to say that one period will go from 0 to 2 pi. So the thing that goes inside here will be 2x plus pi over 3. We will need to solve this for x. So to assist us with the process, I am going to get a common denominator for everything, multiplying by 3 over 3. 2 pi is the same as saying 6 pi over 3. So first thing we'll need to do is subtract pi over 3 from the x values. So subtract pi over 3, subtract pi over 3, and subtract pi over 3. It'll give us negative pi over 3 is less than or equal to 2x, which is less than or equal to 5 pi over 3. After that, normally I would say let's divide by 2. Excuse me. Here I'm actually going to say let's multiply by 1/2. This is due to the fact that we already have fractions in here, and since we already have fractions, we're just going to deal with fractions. X will now go from negative pi over 6 up to 5 pi over 6. That lets us know two things. The phase shift is going to be equal to this negative pi over 6 that we got after the frequency modulation. And the period, we have two options for this. We can either do 2 pi divided by omega. Omega is 2, so 2 pi over 2. Or we can take the ending point of the period minus the starting point for the period. That'll be 5 pi over 6 minus negative pi over 6. And in either case, we will get a period of pi. So let's start with our mother function, y equals the cosine of x. We use values 0, pi over 2, pi, 3 pi over 2, and 2 pi. The y values for the cosine will be 1, 0, negative 1, 0, and 1. We have two horizontal transformations to apply, as well as one vertical transformation to apply. Let's go with the horizontal transformations first. So the first step was subtract pi over 3 from all of our x values. Now subtracting pi over 3 when we already have denominators of 2 is going to be a little bit complicated. So at this step I'm going to get a lowest common denominator of 6. So this negative pi over 3, if I multiply by 2 over 2, we can call that 2 pi over 6. I don't think I'm going to be able to do that for all of these, but what the heck, let's try it. So this will be 3 pi over 6, 6 pi over 6, 9 pi over 6, and 12 pi over 6. Oh man, that last one worked out really well, didn't it? So I'll be subtracting 2 pi over 6. So this will be minus 2 pi over 6. 3 pi over 6 minus 2 pi over 6 will be pi over 6. 6 pi over 6 minus 2 pi over 6 will be 4 pi over 6. 9 pi over 6 minus 2 pi over 6 will be 7 pi over 6. And 12 pi over 6 minus 2 pi over 6 will be 10 pi over 6. Then we're supposed to multiply by 1/2. I'm going to leave the fractions unsimplified as I multiply by 1/2 so that we can figure out what a good x scale will be. So this will be negative 2 pi over 12, pi over 12, 4 pi over 12, 7 pi over 12, and 10 pi over 12. With that in mind, I'm going to select an x scale that will be equal to pi over 12, since that is essentially the common thing that all of these fractions have in common, is something pi over 12. My 1y transformation is going to be multiply the y values by -4. So multiply the y values by -4. What used to be a maximum will now be a minimum. Midline does not change. What used to be a minimum will now be a maximum. Now because this one featured a 2x plus pi over 3 back at the beginning, that's why the phase shift is negative. We are shifting to the left. Now with an x scale of pi over 12, we need 2 of them to the left. That's negative 2 pi over 12, followed by pi over 12, 4 pi over 12, 7 pi over 12, and 10 pi over 12. So important points were pi over 12, 4 pi over 12, and 7 pi over 12. We'll indicate a positive 4 up here, a -4, equal distance on the opposite side, and we're going to start plotting these transformed points. So negative 2 pi over 12, comma -4, will be right about here. Pi over 12, 0. 4 pi over 12, 4. 7 pi over 12, 0. And 10 pi over 12. To make a nice, smooth, continuous graph, connect our local maxima and local minima to our midline points. If we wanted to continue the pattern, then every 3 tick marks we'll have a new corresponding point. Oops, that should be a minimum. Connecting these like so will give us a second full cycle. Domain for this one will be all real numbers. Range, as indicated by the amplitude, is going to be from -4 up to +4.